Well, trigonometers, here we go. This is one of the most misunderstood and, in my not so humble opinion, one of the most poorly taught topics in trigonometry. And that is our a little more in-depth introduction to the unit circle. And a lot of people think they have to memorize. Oh, we had to memorize unit. We had to memorize. No, you don't need to memorize anything. So we're going to talk about the unit circle here and try to make a little bit more sense of it. All right. So we'll go to full screen. Find the right color here. I'm going to start doing the basics in black. What am I doing here? Black. There we go. The unit circle. It always takes me a little while to get my handwriting back when I use the tablet here. I'm not doing this with a mouse, by the way. I do this with a stylus and a tablet. The unit circle, as you recall, is this circle here. This will be tough. Okay, a little lopsided there. But it's a circle centered at the origin. This is the y coordinate and this is the x coordinate. The coordinates of this point are, what is it? It's 1 on the x-axis and 0 on the y-axis. The coordinates of this point are 0, 1. All right, so what does that mean about this? This is a radius, right? This is a radius, so the radius must be 1. So let's write that. R equals 1. Now when we draw a triangle in here, and our definition of the, let's draw a ray in blue. So when we draw a ray that goes out like this at some angle theta, the little circle with the line through it is actually the Greek letter theta. Right? And then we're going to break that into two parts. We'll break that into part of a triangle that goes like this, and then a part of a triangle that goes like this. Let's do it in orange. Green and orange. That doesn't work so hot, but whatever. Okay. And then we have a right angle here. So now, our new definition of the sine and cosine, we can draw this little leg here is the length of that is the sine of theta, and the length of this one here is the cosine of theta. All right. So the one definition of the sine of theta is opposite over adjacent. So what I'm in green here, this one is, cosine is adjacent over hypotenuse, right? So how is it that I'm just saying the adjacent side is the cosine? Well, that's because the radius of this guy here is 1. So if I'm saying adjacent over hypotenuse hypotenuse equals 1. So really, the cosine is on the unit circle is really just the length of the adjacent side. All right, the same applies to the sine of theta. While it's the opposite over hypotenuse, so really that just equals the opposite, right? So that's where our two definitions kind of match, is sine of theta is opposite over hypotenuse, well, it's this over 1. So the sine of the theta is the y-coordinate of the point at which the ray intersects the unit circle. That's our new definition for the sine, or a more useful definition of the sine. Likewise, the cosine. The cosine is the x-coordinate of the point at which the ray intersects the unit circle. So the coordinates of this point are, I'll just draw another one down here so we can make this, it's getting a little crowded. I'm just going to draw the first quadrant of the unit circle. And our unit circle goes like this, roughly. And then I'll recreate this. Sorry, this is a little boring to watch me recreate all this stuff, but I think it's worth your while. So if this is our point, this is our angle theta. Theta goes like that. And then in green we have the cosine, which goes like that. And then in orange we have our sine, which goes like that. What else do I want to draw here? We know that the radius thing is in blue, which is 1. So the coordinates of this point here, the coordinates of this particular point are, and this is where it really trips people up, cos theta sine theta. Okay. Gratuitous use of color here, I know. So the coordinates of this point are xy, but it's also cosine theta, sine theta, right? Because the green side down here, this is cos theta, and the orange side is sine theta. Like that. All right. So on the unit circle, and this only works on the unit circle because the radius is 1. Where's my, there we go. Sometimes I lose this thing. There we go. It only works on the unit circle where the radius is 1, that the adjacent side is the cosine, because it's cosine over 1. The opposite side is the sine. So sine is y, sine is opposite, cosine is x, cosine is adjacent. So that makes the coordinates of this point cosine theta, sine theta, x, y. Let's even write that. I'm going to write that down. So this is y, and then where's my stylus? And green is, so it looks like xy. Okay. Now let's do a quick review here and look at some old school stuff. We recall that we have two kind of special triangles. The one special triangle that we learned about at some point in your mathematical career was this 30, 60, 90 triangle, where this is 30 degrees and this is 60 degrees. Okay, what did we learn about that? We learned that the short side we're going to call x. The long side is, let's see, the short side is x, and the hypotenuse actually worked out to be 2x. And the longer leg here was x times the square root of 3. All right, it just works out for this special case, the 30, 60, 90 triangle, just for this special case, that the sides have these proportions. It doesn't matter if it's 1 mile, 1 centimeter, 1 nanometer, 1 romantic walk, whatever the distance is, right? It'll be twice as long to go on the hypotenuse. Remember, the hypotenuse is across from the right angle, biggest side, smallest angle, smallest side. It always works that way. All right. And then we have this other triangle that also shows up a lot in the real world, and that's why these are so important. Boy, that's a lame triangle, but bear with me. This is 45 degrees, and this is also 45 degrees. So 45, 45, 90, right? All three angles add up to 180. And again, since this has got two of the same angles, if we look at this thing sideways, it's really an isosceles triangle, isn't it? So isosceles triangle has two sides the same. If we call this x, this is also x. And then how long was this one again? This is x times the square root of 2. All right, that's the special sides there. All right. Now, how does this, why am I talking about the unit circle? Why am I talking about these guys here? What if I said that this hypotenuse here actually equals 1. So a special case where I'm saying if I took this triangle and plopped it down over here onto the unit circle, and I said that the hypotenuse equals 1. So now I've got 2x has to equal 1. Well, if 2x, so 2 times this side, has to equal 1, that means x has to equal 1/2. All right? I mean, if I'm saying that the hypotenuse is 1, 2x equals 1, 2x equals 1, then x has to equal 1/2. Or I can say that, I'll do this in green, the cosine of 60 degrees equals 1/2 every time. Every time. And then the orange equivalent of that would be if x equals 1/2, so x times root 3 has to equal, well, I know x is 1/2 already, so I'm going to take that and put it down in here. Equals 1/2 times the square root of 3. And that's a little cleaner to write as root 3 by 2. Okay. So what does that mean? Well, the y-coordinate, the up and down coordinate here, the y-coordinate, is root 3 by 2, so that means the sine of 60 equals root 3 by 2. All right. This maybe doesn't mean a lot to you yet, but we're going to keep charging ahead, and we'll try to pull it together on the next page. We'll do the same thing over here. On a different triangle, let's take this triangle and put it on the unit circle, such that the radius of this particular one happens to be 1. Well, what does that mean? That means that x, so x root 2 in this case is 1. X root 2 is 1. So x times the square root of 2, if I'm saying that has to equal 1, well then x equals, let's see, 1 divided by the square root of 2. Now mathematicians don't like this very much, so what we're going to do is multiply 1 over root 2 times root 2 over root 2, and so that gives us root 2 by 2. Right? So that means this side over here must be root 2 by 2, because that's what x equals. But so is this side. This side, the two sides are the same. So I could say the sine of 45 degrees, which is x, which in this case is root 2 by 2, is the same as the cosine of 45 degrees, equals root 2 by 2. All right. So 3 numbers we kind of have to remember is, I lost my stylus again, 1/2, root 3 by 2, and root 2 by 2. All right, let's redraw these triangles again, and see if we can make some sense of it. And so we'll start these over in black. I'm going to draw a 30, 60, 90 triangle here. So here's 60, here's 30 degrees. If I define this as being 1, which I just did on the previous page, and that means this has to be half of that, which is 1/2, and this is root 3 by 2. And then if I draw a 45, 45 triangle, like that, this is 45, this is 45, and then this is, I define this one as being 1, the hypotenuse is 1, this becomes root 2 by 2 and root 2 by 2. Now maybe that doesn't mean a heck of a lot to you, and it doesn't mean a lot to me, so let's make some approximations. Well, I know that 1/2 equals, well, that's equals to 0.5 or 500, 0.500, right? We know that. Well, I'll also tell you, and this is a number that's going to come up a lot in your life, especially if you go into the sciences, root 3 by 2 is approximately equal to. Now, it's approximately 0.866. Does that make sense? All right. So root 3 by 2, which is a number that doesn't mean a heck of a lot to a lot of us, doesn't mean much to me, but I know it's roughly equal to 0.866. 1/2 is equal to 0.500. This one is bigger than this one. This one is bigger than this one. Oh, sure, if I look at my triangle up here, this side is longer, so this is roughly 0.866. This is equal to 0.500, and this is equal to 1. So the hypotenuse is still the longest side, as it has to be. The long leg across from the bigger angle has to be 0.866, which is bigger than the 0.5. All right, that's nice. Key thing is this is the longer leg, right? So this here is the longer leg. Now, it's a little easier on this one because there's only one number we have to know, root 2 by 2. Likewise, similarly, root 2 by 2 doesn't mean a lot to me. What is root 2 by 2? Is approximately 0.707. And that's going to come up a lot in your life too. All right. So this side is 0.707. This side is 0.707. This side is 1. This side is 1 here. All right. So 0.707, 0.707, 1. Hypotenuse is still the longest side. The two legs are the same because the angles are the same. All right. Now, I've been promising to put it together for a long time. Let's see if we can put this together. I'm going to draw just again the first quadrant of the unit circle over here. And then I'm going to fill this in like this. And let's draw a few angles here. I'm going to draw in, I'm going to shade this in actually. Let's make this one kind of a nice green color. Now let's make this one a nice green color. And then I'm going to make this one a nice blue color. Okay. So if I'm going to draw in a few key angles that show up a lot on the unit circle, I'm going to draw this one, which I'm going to say is, I'm going to extend that out a little bit like this. This is 30 degrees. I'm going to draw this one, also in blue, which is 60 degrees. And then I'm going to split the middle of these two and then draw this one in, which is 45 degrees. All right, why am I doing that? Because now if someone said, what is the, well, let's put in a couple points here. This is 1, 0, and what is this one? This is 0, 1. If someone asked you, what is the sine of 30 degrees? All right, how about let's do first the cosine of 30 degrees. Well, the cosine of 30 degrees relates to this triangle here. So let's draw that one in there like that, cosine of 30 degrees. Well, I know that the cosine of 30 is the adjacent side here. This is the cosine of 30, the side of this triangle. Here's my 30 degrees. It's this triangle, my 30-degree ray. So really, what am I after? I'm after the coordinates of this point. Right? Because if I can find the adjacent side, that is the cosine. But I know the adjacent side. It's the longer side, right? It's the longer leg of one of these 30, 60, 90 triangles. So the longer side has got to be the 0.866. That's bigger than the 0.5. So the cosine of 30 is this side here, which is root 3 by 2. It's the x-coordinate. It's the long leg of a 30, 60, 90 triangle. If I said what's the cosine or the sine of 30 degrees. Well, the sine is the opposite side. In this case, when the triangle is sitting here like this with a 30-degree angle here at the origin, 30-degree angle here, that means this is the short side. The short side of a 30, 60, 90 triangle is 1/2. So that equals 1/2. All right, well, what if we flipped it around? What if I said, what's the cosine of 60 degrees? Okay, so how do we do that? Cosine of 60 degrees, that's this triangle here. Right, it's this triangle. I know it's in this 30, 60, 90 triangle thing. It's in that family. And this time the cosine, which is the x-coordinate, is the short leg of this one, because this is kind of a tall, skinny triangle. I'll draw that one in too. Right. The tall side is the y-coordinate. The short side, the x-coordinate, is this one. So the short side of a 30, 60, 90 triangle, the one across it in 30, is 1/2. So that equals 1/2. And the sine of 60 degrees equals, let's see, the sine is the y-coordinate, right? The y-coordinate in this case is the long leg of a 30, 60, 90 triangle is √3/2. √3/2. All right. Now, you do have to kind of remember these three numbers, 1/2, √3/2, and √2/2. But for the 30, 60, 90 triangle, you know that it's got to either be √3/2 or 1/2, 0.866 or 0.5. You just got to figure out, well, is it the short side is the x or the short side is the y, right? And you can figure that out every time. You don't have to memorize all these different points around the unit circle. What about this one? What about this one? The cosine of 45, let's say. The cosine of 45 degrees equals, well, cosine is the x-coordinate. We'll do this in green. All right, the cosine is the x-coordinate. The x-coordinate, this leg of a 45 triangle. Wait a minute. Both legs are the same. So I know the cosine of 45 is going to be √2/2. And then we also know that the sine of 45 degrees is going to be the y-coordinate, right? Well, it's the same, right? It's an isosceles triangle. That's good for our team. So that's also going to be √2/2. All right. So how do we figure out the sines and cosines of angles? Finding sines and cosines. All right, so I've never done this before. I'm going to make a flow chart. Okay, first of all, the question is, what family is it in? Right, so we'll say, is it in the 30-60 family or the 45-45 family? Okay, so you can decide that basically if it's divisible by 30 or 60, it's in this family. If it's divisible by 45 or 45, well, it's 45. All right, so two numbers to know. So am I interested in the long side or short side? I'm gonna make this an option here. Again, first time ever doing this. You guys are guinea pigs, but hopefully you're enjoying the class so far. But you'll have to get used to being guinea pigs a little bit, because I'm always trying new stuff. So is it the long side or short side? All right. So if it's the long side, well, you know the number you're going to need is going to be something like √3/2. If it's the short side, you know the number is going to be 1/2. Wow, my daughter is screaming upstairs. I heard a thud, and then I heard my daughter start screaming. That's never a good sign. But will charge on here, and I'll trust that Leslie can handle things. All right, root 3 by 2 and 1/2. So then you know that is it positive or negative? And then same deal over here. Is it positive or negative? Make these questions. Short side, long side, positive or negative? All right. Well, if it's a 45-45 triangle, we know the only one number to know. It's going to be root 2 by 2. And then, so we just have to decide, is it positive or negative? All right, so let's put this into practice. We'll draw our whole unit circle here. And I'll just do one quick example. And I'll do a couple examples. I was going to say, because we can do a bunch of these in class, but in case you're not in my class, we'll do a couple examples. So here's our unit circle, unit potato, unit egg. All right. And let's say the cosine. Well, let's label some angles here. There's 0 degrees. Here's 90 degrees. Here's 180 degrees. Here's 270 degrees. Like that. And so let's say someone charges us to find the cosine of 150 degrees. All right. Well, first of all, 150, where is that? It's somewhere between 90 and 180. Right? It's 60 past 90, or it's 30 before 180. All right, so let's draw that in there. Actually, I'm going to do this in color, so we can keep track of these things. We'll do the first one in blue. All right, so we want to find the cosine of 150 degrees. So I'm going to sketch that over here. It's not critical where I sketch it. And I'm going to draw my reference triangle, which makes a corner with the, or makes a triangle with the x-axis. Okay. Well, if I'm looking for the cosine, I'm looking for the x value. All right, so this has got to be the cos of 150. Right. Well, is this the is this the long side or the short side? What do you think? Long side or short? Well, what family? What family is it in? It's 30 degrees short here. It's 60 degrees here. Well, it's divisible. 150 is divisible by 130. So it's definitely this family. Is it the long side or the short side? What do you think? I'm looking for the cosine. Cosine is the x value. X value goes along this way. That's the long side. So it's got to be root 3 by 2. So this equals root 3 by 2. But I said, is it positive or negative? Well, what do you think? It's positive or negative? Well, this is the x-axis over here. And this is the y-axis over here. It's to the left, right? So it's got to be negative. So I'm going to say this is negative root 3 by 2. I didn't have to memorize the cosine of 150, but I know where it is. And with just a few simple asking myself some questions, I can determine that it is, in fact, negative root 3 by 2. Well, as long as we're looking at this one, how about the sine of 150? Right, well, it's the same triangle, 150 degrees here. But this time it's the short side. The short side is on the y. Where's my stylus again? There it is. The short side is on the y. And so the y-axis is the sine. That's what I'm interested in. So the short side is 1/2. So it's 1/2. Is it positive or negative? Well, I'm going up. I'm going up on the y-axis. So it's positive 1/2. All right. Let's do another one. Let's do this one in purple. Let's say, what is the cosine of, let's say, 315 degrees? Equals. Okay, well, where is 315? Here's 270. Here's, oh, this is 360. I'll fill that in. Here is 315. Well, it's 45 past this. It's 45 short of this. So we'll draw it in roughly here. What family do you think that's in? 315. Well, 315 is divisible by 45. It's 45 past one of our key spots. It's 45 before one of our other key spots. So we're pretty sure this is in the 45-45 family. So we draw an angle up like that. And this is the cosine is this way, the sine is this way, the cosine is this way. There's only one number I have to know for the 45-45 family, so that's root 2 by 2. Well, now we have to know is it positive or negative. The cosine is this side here. The cosine, it's going in the positive x direction, so that's positive. Right? What about the sine of 315 degrees? Okay, well, the sine is the y value, so I'm going this side, right? Both sides are the same. They're both root 2 by 2. Right, that's what I like about these triangles. Root 2 by 2. Except this time the sine, the y value is negative, because I'm going down here to this point. So I know it's negative. Root 2 by 2. Okay, we're going to do a lot more of these in class. If you're somewhere out of my class and watching this, I hope that cleared some things up. But there's a lot of angles you could know. We'll do one more page, yeah, as long as we're on a roll. So I will draw one last master unit circle, and we're going to break all these up and kind of figure out what they are, because you should be able to knock this off in a very short amount of time. Ooh, this could be one of my best. Ooh, it's going to be a unit football. Oop, unit, I don't know what it is, unit something. All right. So we're going to break this up into a bunch of families. So I'm going to do the blue is in 30-60 again, so we'll do the blue ones. We've got over here 30 degrees. We've got here 60 degrees. And then we've got 90 degrees. And then we go 30 degrees past this. And we've got 120 degrees. And then here we've got 150 degrees. And then 180 degrees. And then we go 30 degrees past that. What's 30 past that is 210 degrees. 30 past that is 240 degrees. And then we've got 270 degrees. 30 past that is 300 degrees. Oop, 300 degrees. And then 30 past that, wow, that's terrible. 330 degrees. And then finally we get to 360. And that was 0. All right. So if we're trying to find the sines or cosines of any of these, sines and cosines, we know it's going to be either 1/2 or root 3 by 2. And then so we have to figure out, is it plus or minus or plus or minus. Okay, the other family, we'll do that in green, is this family, 45 degrees. Oh, 90 degrees also fits in this category. And then we'll go up here, let's see, 90 plus another 45 degrees is 135 degrees. Then plus another 45, we land ourselves at 180. And then this one is 225. Yeah, bigger than 210, smaller than 240. So 225 degrees. And then I guess that also fits in here. So this is 270 degrees. And then we have this last one that goes like this. That was a better line. 315 degrees. And this is really bothering me, so I'm going to fix this. Make some better, hello, better handwriting there. 300 degrees. Okay. So then for the green ones, we know that for the sines and cosines, right, it's just going to be plus or minus, and because there's only one number we have to know, that's root 2 by 2. We just got to figure out, are we talking about going in the positive direction in the x direction, positive direction in the y direction, to determine if it's plus or minus. That's it. All right. I hope this helped. I hope you never have to memorize the unit circle. You just understand kind of where stuff is, what stuff is, long side, short side, positive or negative. Catch you later.